So trigonometry is the study of the relationships of the sides of triangles. Specifically, we're going to deal with right triangles right now, okay? Now, a trigonometric ratio is basically a ratio of the lengths of sides of a right triangle. So a right triangle has 3 sides. If you take any 2 of them and find the ratio of the lengths, that's a trigonometric ratio. The 3 most common trig ratios are sine, cosine, and tangent, and they are abbreviated, right, like this, okay? Remember SOHCAHTOA? We did SOHCAHTOA last year? Yes. Okay, so here are the trig ratios, and the way it's read, so for example, sine of theta is how you read it, okay? It's written as sin theta. So that symbol, it's like a 0 with a horizontal line inside of it. This is the Greek letter theta. Okay? So for example, you know, like Thanos, right? That's like the Greek letter. Like that would be like, it's that th sound has its own letter in the Greek alphabet. Okay? It makes that th sound. And it's, okay, it's not feta like the cheese, right? It's theta, th. So now to read this, please, pet peeve. This is not sin, it's sine, okay? So let's have some respect for these, you know, trig ratios here. So sine of theta. Theta is also the symbol that is most commonly used for an angle, okay? Yeah. Question?
Oh, no.
Oh, so the sine of theta, so if you have an angle, if you have your right triangle here, and suppose this is the angle theta, whichever one the angle theta is, then the sine of theta is just the ratio of the length of the opposite side to the hypotenuse, okay? So if that's theta, then the cosine of theta, which is that, not cos theta, please, okay? Then it's just the ratio of the length of the adjacent side to the hypotenuse. And then the tangent of theta, which is written like this, is the ratio of the leg opposite to the adjacent of theta. Okay, are we all okay with how to label opposite, adjacent, and hypotenuse? Yes? Okay, so these are the trig ratios. By the way, show of hands. If you didn't do geometry with us last year, show of hands. Did you do it in your own school last year?
I got time.
Okay. Okay. All right. So, okay. So then, suppose this is. Okay. So suppose this is the angle that we're talking about, right? This is the angle theta. This is a right triangle, right? Right here. The side opposite to the right triangle is always the hypotenuse. So that's always the side opposite to the right triangle. Now, this theta is going to be not the right angle. It's going to be one of the other angles. So suppose this is the angle theta. Then you have one leg here and one leg here. This leg that's touching theta, adjacent means touching, that is called the adjacent leg. And then the one that is not touching is the opposite leg, or the opposite side, all right? So whenever you get your angle, you're always going to label opposite, hypotenuse, and adjacent. Okay, so these you would probably have seen in geometry, sine, cosine, and tangent. Now, you can take these 3 and you can flip them around, take their reciprocals, and the reciprocal functions are the following. You've got cosecant. Cosecant is the reciprocal of sine. So if sine was opposite over hypotenuse, this is the reciprocal. Hypotenuse over opposite, okay? Then secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. Okay, so cosecant, that's how this is read, not CSC, is the reciprocal of sine, secant, cosine, and so on. Okay, so cotangent and tangent, nobody has any issues with, you know, them being related to each other, right?
Yeah.
What people, what people think is that, you know, the other one should be flipped. However, okay, they're not, sadly. There is another reason why, you know, they are like that. So the way I tell my students is, you know, half of these start with a C, half of them start with an S, and you have to match like opposite ones to each other. So a cosecant matches with a sine, and a cosine matches with a secant. That's how I kind of think about it, right? An S matches with a C, and S matches with a C. Okay? That's how, you know, there is no other, because there is no other like reasoning behind why they're called what they're called. The Greeks called them this, and one day if you build a time machine and you go back, it can be like, look, buddy, like this is not working in 2022, okay? Yeah, Pythagoras, right. Okay, so let's find the 6 trigonometric functions for the angle theta. So the first thing you want to do is identify where theta is. Theta is this one. Once you determine where theta is, you then have to proceed and label your sides. Label the hypotenuse first. It's always the easiest one. It's the longest side facing the 90 degrees. So between the 8 and the 15, which one is the adjacent to theta? 15, and then this is the opposite. So now, okay, so remember SOHCAHTOA, right? I'm only going to write it for people that haven't seen this before. So sine of theta, the way this works is sine is opposite over hypotenuse, all right? For my 9th graders that I didn't teach geometry to last year. Opposite over hypotenuse. So opposite is 8 over 17. You have to make sure that this is a simplified fraction, and then you're done. Okay. Cosine of theta is adjacent over hypotenuse, 15 over 17. Tangent is opposite over adjacent, 8 over 15. Now, once you do this, the reciprocals are cosecant of theta, secant of theta, cotangent of theta. There is minimal thinking here. You just take the reciprocals of the ones above. Okay, now, how to lose points if you're interested. Here's how to lose points, because this is an honors class. Sine, cosine, all of these none of these can exist without an angle. So it can never be sine equals blah, blah, blah. Sine of what? Sine always has to have an angle. Sine of theta. So if I see this is not going to be full credit. Never, ever, ever. Okay? I'm not going to do the corny pun and say it's a sin to do that. You just know. Yes? Okay. All right. Told you it was corny. Okay. So now sometimes you don't have a triangle written, given to you, but it's okay because we can draw our own. Tangent of A is 5 over 2. Okay, this tells me there is a triangle with an angle A. So draw yourself a right triangle. You can orient the right triangle however you want. Just label one of the acute angles A. Now, this tells you tangent is 5 over 2. Well, tangent is opposite over adjacent, correct? That means if this is angle A, the opposite to it has a length of 5. The adjacent to it has a length of 2. Well, to find the other ones, I also need to find the hypotenuse. How do I find the hypotenuse? Good old Pythagoras to the rescue. 2 squared plus 5 squared is equal to x squared. So x is root 29. A lot of this will be no calculator, so you have to just leave it in simplified roots. So this is root 29. So now sine of A is going to be opposite 5 over root 29. We got to rationalize though. So we get this. Yeah, right. So now cosine of A is 2 over root 29, which is 2 root 29 over 29. Okay, tangent is already given, so we don't have to find it. Notice it says the remaining 5. So now let's do the reciprocals. Cosecant. Okay, for the cosecant, when you have this situation, go with this one. Go with the unrationalized. So it's just root 29 over 5. Okay, secant of A, root 29 over 2, and cotangent of A, 2/5. Okay, I'm just going to draw a happy face here just to express how happy I am. Okay? All right. So, next. All right. So okay, we have an angle, the value of the angle given, right? And we need to find one of the missing sides. So again, we have to use SOHCAHTOA. Now, always, always, always identify the angle that you are working with. Okay? That's the angle 24. What do we have? We have 2 sides given. Label them. X is the hypotenuse and 11 is the adjacent? No, opposite. Good. So I have opposite and hypotenuse. Which of the ratios is that? Sine, cosine, or tangent? It's sine. So remember, it's always sine of the angle. What is the angle here? 24 is equal to 11 over x. And now we have to solve for x. So cross multiply, because now we're experts at all of this. Oh my God. Yeah, so it's easier. So then x is 11 over sine of 24. Okay, go ahead and take out your calculators, please.
Will we ever have to know how to solve sine out of calculator?
Yes. Yes to all. Okay, so so take a look. We're in this home screen. So here, trig. So we're gonna do 11. Oh, sorry, I take that back. Escape. Okay, so we're gonna do 11 divided by sine. Sine is in this. Look, sine. So it's 11 divided by sine is in this button here where it says trig. You have a whole slew. Everything is here. So sine of 24. Now, before you press enter, right next to your battery, does it say RAD or DEG? Okay, so it should say DEG. So right now, when we press enter, it's the right expression, but not the answer that we want. So there are a couple of ways to change this. Don't freak out on me if the first one doesn't work. One way is you can bring your cursor over and hover on top of the RAD and just click, and sometimes it toggles to degrees. Okay, raise your hand if it did not do that for you. Oh, fantastic. So now you can just bring this one back, press enter, and look at what a different answer you get. Do you see how different the answer is? So many students have lost many points because their calculator was in the wrong mode. Guess whose job it is to put their calculator in the right mode? There you go. Yep. Okay, we're going to do all of that in this chapter. Okay, so this is going to be 27 degrees. Yes, I'm sorry. DEG, degrees, because, okay, so this is going to be 27.0. Do you see how your angle is in degrees here? That's what tells you that your calculator should be in degrees. Yes? All right, so moving on. Okay, special right triangles. Okay, so special right triangles, we have 2 of them, a 30, 60, 90, and a 45, 45, 90. In a 30, 60, 90, you have the hypotenuse and the two legs. One short leg, one long leg. Okay, the short leg always faces the smaller angle, right? 30 degrees faces the short leg. So this is the short leg. Raise your hand if you have not seen special right triangles before. Okay, so this is the long leg. The rule is the long leg is always short times √3. Okay? So the long leg is always short times √3. The hypotenuse is the short leg times 2. Always. Okay? So now, let's go ahead. Okay, so sine of 30, 3 times 2. So sine of 30, if this is your 30-degree angle, opposite over hypotenuse, it's going to be x over 2x, which is a half.